Alright, so in this video, I'm going to be solving the problem 2 to the power of 20 minus 1. So I want to find the value of 2 to the power of 20 minus 1. So to solve this, what I'm first going to do is I'm going to rewrite 2 to the power of 20 as 2 to the power of 10 times 2. So now I have 2 to the power of 10 times 2 minus 1. And if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 10 times 2 is equal to 2 to the power of 10 to the power of 2. And I have this minus 1. Now 1 I can rewrite as 1 squared because 1 is the same thing as 1 squared. So now I have 2 to the power of 10 to the power of 2 minus 1 squared. And the reason I put this in this form is because now I can use the property a squared minus b squared is equal to a plus b times a minus b. So in this case, a is equal to 2 to the power of 10 and b is equal to 1. So now I get 2 to the power of 10 plus 1 times 2 to the power of 10 minus 1. Now 2 to the power of 10 is equal to 2 to the power of 5 plus 5, which is equal to 2 to the power of 5 times 2 to the power of 5, which is equal to 32 times 32, and 32 times 32 is 1024. So I get 1024 plus 1 times 1024 minus 1. Now 1024 plus 1 is 1025, and 1024 minus 1 is 1023. So now I have 1025 times 1023, and to solve this, or to multiply these two, I'm not just going to do it using the basic multiplication method because this takes way too long. Instead, what I'm going to do is I'm going to rewrite this as 1000 plus 25 times 1000 plus 23, and now I can distribute my 1000, so I get 1000 squared plus 23 times 1000, and now I can distribute 25, so I get 25 times 1000 plus 25 times 23. Now 1000 squared is equal to 1 million, so I have 1 million plus 23,000 plus 25,000 plus 25 times 23, which is 575. So now from here, 23,000 plus 25,000 is 48,000, and 48,000 plus 575 is 48,575, and that plus 1 million is 1,048,575. So this is my answer to this problem. Alright, so in this video, I'm going to be solving the equation x to the power of 3 is equal to x to the power of 5. So my only variable in this equation is x, so that's what I'm going to be solving for. And now for my solution, I'm going to rewrite my equation down here so I have a little more solving space. So my equation x to the power of 3 is equal to x to the power of 5. And what I'm first going to do is subtract x to the power of 5 on both sides. So then these two cancel out, and I get x to the power of 3 minus x to the power of 5 is equal to 0. Now, from here, x to the power of 5 is the same thing as x to the power of 3 plus 2. And an important property of exponents is that if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So x to the power of 3 plus 2 is going to equal x to the power of 3 times x to the power of 2. And now I'm going to factor out x to the power of 3. So I get x to the power of 3 times 1 minus x squared. So now this gives me two equations. I get x to the power of 3 is equal to 0, and I get 1 minus x squared is equal to 0. So for x to the power of 3 equals 0, I'm going to take the cube root on both sides. So I get the cube root of x to the power of 3 is equal to the cube root of 0. The cube root of x to the power of 3 is x, and the cube root of 0 is 0. So x equals 0 is one solution. Now for 1 minus x squared equals 0, I'm going to rewrite this as negative x squared plus 1 is equal to 0. And now I'm going to multiply both sides by negative 1. So negative 1 times negative x squared plus 1 is equal to x squared minus 1. And 0 times negative 1 is 0. So I get x squared minus 1 equals 0. And 1 is the same thing as 1 squared. So I have x squared minus 1 squared is equal to 0. And if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So this is equal to x plus 1 times x minus 1 is equal to 0, meaning I get two equations, x plus 1 equals 0 and x minus 1 equals 0. For x plus 1 equals 0, I get x equals negative 1. And for x minus 1 equals 0, I get x equals 1. So notice how we have three equations for this equation. Notice how we have three solutions for this equation.